We are discussing about electricity, and first thing in this one is electric current. So what is electric current? Basically, electric current is a rate of flow of charge. So inside metals, if you see any metals or anything, if you see any materials inside metal, there are so many electrons. If their electrons are there, so what will happen? If I apply any current in this one, electrons start moving. So rate of flow of that charge. So rate of flow of that charge is called current. What is current? Rate of flow of a charge. Now, mathematically, if you want to write it, how will write it? I is equal to Q divided by T, charge divided by time. And what is unit of charge? Coulomb, and unit of time is second. So coulomb per second is a unit of a current, but we have another unit of current that we call ampere, and we denote this one by capital A. One more thing, it's a scalar quantity, but with direction. So this is a scalar quantity and it have a direction as well. So this have a direction, current have a direction. Okay, but it still it's a scalar quantity. Basically it's a tensor quantity, but we say it's a scalar one. In running language we can say it's scalar. Now we are talking about charge. What is charge? Charge is a fundamental properties of a matter. It's a basic property, just like mass, color. It's a fundamental properties of matter. That's why charge is the same like that one. Charge is also fundamental properties of matter. So if I ask you what is charge on one electron, everyone knows charge on one electron how much? That is the minimum possible charge, 1.6 into 10 raised to power minus 19 with negative sign. It's not positive charge, it's a negative charge. All right. Now if I ask you in 1 coulomb how many charge will be there, so you can divide by this whole thing, and if you divide this one, you will get approx 6 into 10 raised to 18 number of a electron. So in 1 coulomb this many electron will be there. Now next thing in this one is electric potential. So we have one conducting wire, any metal, and we are connecting this metal by battery. Now when you are connecting this metal by battery, so whatever number of electron will be there, they will experience some force because of this battery. So even when they will experience some force, so obviously there will be work done, means battery will do some work on them. So if battery is doing some work on them, so work done per unit charge, W divided by Q, we say it potential, electric potential. Okay. Now, what should be unit of this one? We know unit of work done is joule and unit of a charge is coulomb. So it should be joule per coulomb. But we have another unit for this one is that is called volt, and volt is unit of a electric potential. Now, it's also a scalar quantity. Why? Because work done is scalar quantity and charge also we say it's a scalar. So it's a scalar quantity. So it's a scalar quantity that don't have a direction also. Means no direction and it's a scalar quantity. Unlike a current. If I have a one battery like this, then we have one ammeter and we have one voltmeter and we have one resistance. So we have a battery, ammeter, voltmeter and resistance. So this is what ammeter, this one is what voltmeter, this one is what resistance. We are representing this one by R. So what happens if I have one battery and I am connecting this circuit? This is the basic circuit. There can be so many things, key and all, but this is the basic circuit right now. So if I am connecting this one by ammeter and I am connecting this one by voltmeter and there is one resistance in between. So what will happen? I am connecting one battery, there will be some current in ammeter. Now I connect two battery, there will be another more current. If I connect 3 battery, 4 battery and keep on doing this thing, if I keep on adding the battery, it means more number of battery, more amount of current will be there. More number of battery, more amount of current will be there. It means V directly proportional to I. So if V directly proportional to I, so if I remove this proportionality, so I can write V is equal to I into R. R is what? R is constant right now, and R I can also write V divided by I. It's a simple math. I can write V divided by I. V is voltage and I is current. And R is a simple constant. What is simple constant? And name of this simple constant is what? Resistance. What we say, this is resistance of a wire or any material. So what is resistance? Basically it's a ratio of voltage and current, but this is only in case of a conductor. I am talking about conductor. We know 3 type of material. One is conductor that conduct electricity easily, just like metals. Another is insulator that does not conduct electricity easily, just like a wooden block, carbon, something like that. And we have insulator, we have a semiconductor that sometime it conduct electricity, sometime it does not conduct electricity. What is meaning of sometime? At some temperature it's easily conduct electricity, at some temperature it does not conduct electricity. Example of this one is silicon and germanium. But right now we are not talking about semiconductor, we are not talking about insulator, we are talking about conductor. So this is applicable only for conductor. So whatever formula is written over here, this is only applicable for conductor. So this is only applicable for conducting material. So if I make graph between V and I, so this is what I, and this one is what V, this is voltage and this one is current. And for conductor, if I'm making graph, so this graph must be straight line, and this angle is what? Theta, and this tan theta is equal to V divided by I, and you had seen this one V divided by, you can also say R. It means R is equal to V divided by I is equal to tan theta. It means if there is a graph between V and I and they are asking for resistance, so simply what you have to find out? Tan theta. That is also called slope of a graph. So we had seen R is equal to V and V divided by I, but R does not depend on V and it does not depend on I as well. So depend on what? It depend on geometrical construction. Geometrical construction means it depend on length, it depend on area, it depend on material, but it does not depend on V upon I. Then you ask like why it does not depend on V and I, we can see in the formula. So if I multiply V by 2, ultimately I will be also multiplied by 2. Why it is so? Because we already know V directly proportional to I, and this statement V directly proportional to I, this statement is called Ohm's law. So this one is Ohm's law. What is Ohm's law? V directly proportional to I. So if I make V 3 times, I will be also 3 times. V 4 times, I will be also 4 times. It means R does not depend on voltage and current, so it depends on something else. So something else means what? Let's say we are having one wire. So if I have L length of this wire, so if length will be more, it's difficult to conduct electricity. Like electron won't flow easily if length will be more. It means length is more, it's providing more resistance. It means R directly proportional to L, R directly proportional to length of a wire. Now if I have another wire, let's say we have another wire, cross section area of this wire is more than first one. So more cross section area means this one area. So if area will be more, it's easier to flow. If area will be less, it will be difficult to flow. Means R directly proportional to 1 upon area. Okay. Now if I combine these two, I can write rho L divided by A. And rho is what? Again it's a constant, and this constant is called resistivity. This is resistivity. So there is a difference between resistance and resistivity. Resistance depend on L, resistance depend on A, resistance depend on rho, and R is what? Resistance. So basically this is the formula for resistance. And what is difference between resistance and resistivity? Resistance is a property of a body and resistivity is property of material. What is meaning of this one? Let's say we have a 2 block. This is iron block Fe and this one is also iron block Fe. Now we have a 2 block and their size are different. So their resistance will be different one because it's a property of a body. Their dimensions are different. But resistivity will be same. So resistivity of this one will be same. This one will be also same. Why? Because they are made of a single material. And what is single material? This is Fe and this one also Fe. So this is difference between resistance and resistivity. We have done 3-4 topic. First current, then voltage, then resistance. Now we are solving question based on that formula. So now we have done one formula. V is equal to W divided by Q. We have done this formula. It means what? W is equal to Q into V. So what is Q given in this question? If you read this question, what is given? How much work is done moving charge 2 coulomb across 2 points having potential difference 12 volt. It means Q is given. Q is how much? 2 and V how much? 12. So Q into V, that is 24. And what should be unit of this one? Volts. It's a simple question and it's taken from the NCERT. It's a solved example from NCERT textbook of a 10th grade. Alright, now it's given resistance of a metal wire, length 1 meter. So L is given 1 meter and what resistance? 26. Resistance is 26 and diameter of wire, if you see, this is 0.3 millimeter And what is the resistivity of the metal at the temperature, at given temperature? What is given temperature? 20 degrees Celsius. So basically in this one, in this numerical, there is no meaning of this temperature, but okay, but it's a given, so we will solve it. So just it's a given, that temperature is given. Basically in this one there is no meaning of that temperature thing. All right, now if you see, this one, value of R is given to you, that is 26 ohm. So value of R is 26 ohm. And what is L given? L is equal to 1 meter, and diameter is given, diameter is equal to 0.3 millimeter. It means it will be 0.3 into 10 raised to minus 3 meter. Just I converted millimeter to meter. That is diameter. But what's the radius? Radius will be R is equal to, you can write 0.3 divided by 2 into 10 raised to power minus 3 meter. Now we have a formula. I have to find out resistivity. R is given to us, this one. L is given 1 meter. Area we can calculate. How to calculate area? Area is equal to pi into r square. We know already what is value of r, so pi into r square is area. So let's say calculate areas. Area is equal to 3.14 into r ka square. R ka square means this value, 0.3 divided by 2 into 10 raised to power minus 3 ka square. So you'll get this one. So this is area. Now we can rearrange this formula. If we see R is equal to rho L divided by A, I can also write this formula. If I want, I can write rho is equal to R into A divided by L. And R is given how much? It's a 26, and area is given 0.15 into 10 raised to power minus 3 ka square. If we solve this one and divide by L, what is L? On meter. So if we solve this whole thing, so we will get, if I divide by 1 over here, and if I solve this one, so whole thing I'll get 1.84 into 10 raised to power minus 6. It's a resistivity. And it's a given one thing. Look at the table 12.1, 12.22. Look at the table 12.2. It's written over here. Look at table 12.2, and you find out what is the material name. So you can see the NCRT in table 12.2. So if something have a resistivity this much, 1.84 into 10 raised to power minus 6, it means we are talking about that material only. That's it. Thank you for watching.